All right, guys, in the previous worksheet, we talked about a small number of molecules or a small number of atoms, say 4 atoms of sodium or 8 molecules of oxygen. But in reality, that's just impractical. Even if you took the tiniest speck of sodium you could possibly get, it would have billions of atoms in it. So when we're doing this, we're not going to be talking about individual atoms and molecules, or even billions of them, but rather moles of atoms and moles of molecules. Now, if you've forgotten what a mole is, it's totally fine. Let your teacher know. Go back and redo the moles worksheet and then come back to this. But if you remember what moles are, let's get into this. Here's the first question. You have 4 moles of sodium and 3 moles of chlorine gas. How many moles of NaCl will you produce? Let's take a look at how we set this up. We begin the way you always start anything in chemistry, with a balance equation. So let's start off with this balance equation. Here it is. 2Na plus Cl2 produces 2NaCl. And I've already balanced it. Now, this is the equation. These numbers, these coefficients, are not changeable. This applies to all combinations of sodium and chlorine in the universe. In the entire universe, you need 2 atoms of sodium with plus 1 molecule of chlorine to produce 1 molecule of sodium chloride. That's the whole universe. That's not specific to this problem. So where are we going to put the information that is specific to this problem? I'm going to tell you where, right underneath it. We're not going to change this. This is set in stone. We're going to put the information right underneath, all right? Let's take a look. The equation's the same. Now you have 4 moles of sodium and 3 moles of chlorine. Now we need to start thinking. I want you to think about one thing, which is what are you going to run out of first? Now you have, it takes for every 2 of these, you need 1 of these. So what will you run out of first? Well, if you use all of the moles of sodium, use all 4 moles of sodium, then you would only need 2 moles of chlorine, because you need twice as many moles of sodium as you do of chlorine. So you're going to run out of sodium first. That means sodium is the limiting reagent, it's the limiting reactant, and it's going to determine how much of the product you're going to produce. Now notice here that for every 2 Na, you produce 2 NaCl. So if you have 4 moles of Na and you use it all up, it's going to produce 4 moles of NaCl. Let's take a look. Now, I've marked this in red to let you know that this is the limiting reagent. You could also circle it, whatever. Make sure you know what the limiting reagent is. That's the thing that you run out of first, and that's going to determine how much of the outcome you produce, how much of the product you produce. In this case, that's sodium, and so you have 4 of these, and over here we realize that if you have, for every 2 of these, you produce 2 of these. So if you have 4 moles of these, you also get 4 moles of these. And that's how you use moles in stoichiometry.